All right, I believe we talked about how this one's a little bit different because of the starting value. And so I wanted to make sure we talked about this in preparation for, I don't know, some sort of summative assessment that may happen in the very near future. Are we okay with G of 3? Yes? All right, what do you have to... Are you sure we did G of 3? Yeah, that's right. Okay. I remember. Yeah. Pi minus a half, was it? Okay. All right. Now, G of 3 was pi minus a half. Does that mean at 3... How do I word this? That tells us the location at 3. Agree? Does that tell us how far the object has been displaced from -2 to 3? Not necessarily, right? We would need to know the whole area there and kind of work backwards to figure out where was the particle when we started at -2. Do you agree with that? All right. Find all values of x on the open interval at which g has a relative max. Okay, so you should really be thinking in calculus terms here. And I know that sounds obvious, but sometimes we want to jump in with words or say, well, the g function is going up and then it's going down. And well, just break it down using the fundamental theorem. If I want to look for where g has a max, that's where g prime changes from positive to negative. So g prime of x, if I take the derivative of the left side, I have to take the derivative of the right side, which is f of x. So if I'm looking for where g prime changes from positive to negative, I'm looking for where f changes from positive to negative. Where does that occur? 2. So x equals 2. All right, justify your answer. G prime, which equals f, changes from positive to negative at that value. Okay? You with me? Write an equation for the tangent line at a tangent to the graph of g at 3. There's 2 things I need to write the equation of a tangent line. Point and a slope. And it's a point on f? No, point on g. So I need to know g of 3. What is g of 3? Oh, look, we found it earlier. Pi minus a half. AP test writers love to do that. If you need a point, they'll usually have asked you that question up above. All right. And what else do we need? We need, tell me in a calculus way. We're to that point in the year where you can give me the notation as well. We need g. Good. I need the slope at 3, right? G prime of 3. Well, isn't g prime of 3 f of 3? What's f of 3? -1. There's my slope. There's my point. You can take it from there. Y minus y1 equals m times x minus x1. Leave it in point slope form, and you're done. Good? All right, last one. Bless you. Find the x-coordinate of each point of inflection of the graph of g. Well, an inflection point will happen when g double prime changes sign. Well, g double prime is equal to f prime. So if we're looking for where g double prime changes sign, we're looking for where f's slopes change sign. You're looking at f. F's slopes are positive, 0, negative. Did f prime change sign? At 0. Ready? Negative, 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 negative. Still negative, 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 negative. No change in sign. And then positive. So at 0 and at 3. Agree? X equals 0. X equals 3. Because g double prime, which equals f, changes sign at those points. That will give you full points for the explanation. You want me to repeat that? Awesome. We've reviewed that type of problem several different ways. Any questions on those? Wendy.
Can you do part C again?
Sure. We need a point and a slope on G at 3, right? G of 3 we got from part A. Are you good with that?
Yeah.
Okay. So there's our point. So our point is 3 comma pi minus a half, which is ugly, but don't say it. Don't tell it that. It's a little sensitive. All right. And then G prime is, slope is -1. That came from G prime of 3. G prime of 3 is f of 3. We're given the graph of f. So I can actually go up here and say f of 3 is -1. See where I got that from?
Yeah.
And then I just write my equation of my tangent line. Y minus pi minus a half. I don't know why I did that. Pi minus a half equals m, which is -1, times x minus 3 is your tangent line. If I'm on the AP test, I'm not even spending time distributing that negative. They'll accept ugly answers. Questions on that? All right. You were also asked to do a portion of the review. That portion being, I believe, was it 1 through 3 or 1 through 4? 1 through 4. All right. Number 1, you need to be able to take this antiderivative by hand. What do you need to do first? You should look at that and say, I don't know that rule. I don't have a rule for that. And it's not ln. Don't ln. Do you know that? What do you have to do? Make it 4x to the -2 first. Add 1 to the exponent, divide by the new exponent. Plug in 2, plug in 1, subtract. You just see that? Are we good? Good? You see it? Good? Good. If you want to see it, ask me. All right. Number 2. You should look at that and say, I don't know that rule. But it's t to the 1/2. So I can move it up as t to the -1/2. I'll do a quick little help you out with some work. Remember, if we're going to rewrite it, we need to keep the integral. If you rewrite it, you need to keep the integral. If you anti-differentiate, you need to drop the integral. Well, I'm ready to anti-differentiate. I add 1 to the exponent. What do I get? 1/2. Divide by the new exponent. Divide by 1/2, same as multiplying by 2. So 2t to the 1/2 plus a constant. Drop the integral. I go from 1 to 4. Plug in 4. Plug in 1. Subtract. Avery, you good? Want me to work it out? Okay. Plug in 4. Two times 4 to the 1/2 plus a constant. Plug in 1. 2 times 1 to the 1/2 plus a constant. And subtract. Well, 4 to the 1/2, anything with the 1/2 power is square rooting it. So I have 2 times 2 plus c. I have 4 plus c. 1 to the 1/2 is 1. So I have -2 minus c. I get 2 for that answer. You guys get 2? 2 is the area between the function and the t-axis from 1 to 4. How would I find the average value? Good news. You really don't have to do much more work. Average value would be the same thing, but with a what out front? A 1/3. Where'd that come from? Oh, 1/b minus a. 1/4 minus 1. Average value. So I don't really need to do any more, do that again. I already know what the integral part is. It was 2. 1/3 of 2 is 2/3. Three. What's the antiderivative of secant x tangent x? Secant x plus a constant, plug in 0, plug in negative pi over 3, and subtract. Okay? And 4. How do we do on 4? I forget. Did I put the answers on there? Mm-hmm. Yes. Okay. You guys check it? Did you get it right? Do you need help? All right. Let's do 5 and 6 right now. I'm going to amateur move. All right, I'm going to put 5 down here. Whoa, 5. Calm down. All right, I'm going to put 5 down here so you guys can do 5 and 6 without me scrolling. Deal? We're going to need to start the quiz at 10:40 at the latest. Oh, Jackson. We're going to miss next year. Go for it. Where are you going to school? You're still undecided. Where you want? Haven't narrowed down to a couple? What are your choices? Yeah. Your plans, Tyler?
Same things for Canada State. You can for aerospace engineering.
Big ideas, guy. All right, who wants to help me out with 5? No one? Thanks, Tyler.
So it's F of E was big F of E minus big F of A, so it's F of big F of 2x minus F of x, but it's 2x, you have to multiply by 2.
Do you know what big F is of that?
No.
Do you guys know what big F of T is? Or does it not matter? Doesn't matter because we're taking the derivative of the big F, so we're going to get back to this. So I
probably did right.
I think you did. I'm just making sure that the explanation is clear as well. So go ahead and give me your answer, Tyler.
I got 2 over 4x squared plus 1 minus 1 over x squared plus 1.
You guys agree? I agree. This is a squared. There's some confusion over here. Dom. Okay, so the short answer or the long answer? It depends on how well you understand the fundamental theorem. Like, feel pretty good? Okay. So this, if I were to do, ignore that. Okay, ignore that. If I were to do this, I would need to know capital F, I plug in 2x, capital F, plug in x, and subtract. But we're taking the derivative of that. So the derivative of big F of 2x is little f, plug in 2x, 2x quantity squared is 4x squared, and then multiply times 2 since it was a chain rule. Okay, it was big F of 2x. The derivative is little f of 2x times 2. So here's little f of 2x and then times 2. This minus little f of x times 1. Well, there was a chain rule, but the inside derivative of x is just 1. So there's just a 1 up there. Make sense? You guys good? Everybody good? All right. Now, did we know the antiderivative of this? Tangent inverse of t plus a constant. 1 over 1 plus t squared. It didn't matter. It didn't matter. All right. Trapezoidal sum. What'd you get for that? 97? Agree? Any questions? Mr. Lippy. How are you? And then the old FTC. All right. So I'm gonna show you the graph. It's defined. M is defined as the integral from 0 to x. 0 to x. Go ahead and work together to get those. We'll go over it in just a minute, and then we'll start our quiz. How many of you already attempted this last night? All right. Madison.
I think you're spelling facts on stuff. Then concave down. Okay. Well, M double prime. So it's when F is.
All right. Who wants to take the easy road out and do the first part? Who's got A? Cole. 0. You guys agree?
Yeah.
On what interval is M decreasing? M decreasing. Madison.
0 to 6.
And Y.
M prime is the sum of F
Good. M prime of X equals F of X. Good. And if we're looking for where M is decreasing, that's where M prime is going to be negative, which is where F is. And F is negative from. Perfect. Who wants to take part C? Dom.
6 to 10.
And Y.
Because you have to.
So M double prime is F prime of X. Try to link those together on the AP Calc test. Try to link those together. Say M double prime equals F prime. And if we're looking for where M is concave down, we're looking for where M double prime is concave down. M double prime is Negative. Yep. Put you on the spot. And M double prime is negative when F primes are. These are equal. Equal. Are you with me? M double prime is negative when F prime is negative. Be careful because people, it's not just you, all over the test and quizzes for this chapter, people get the word negative and decreasing mixed up all the time. Keep it straight, okay? M, watch. M prime, M double prime. Back to chapter 3. No, chapter 4. First derivative test. Second derivative test. Ready? M will be concave down. Let's work backwards. What test were we doing? Second derivative test. M will be concave down when M double prime is negative. Oh, okay. So I'm looking for where M double prime is negative. It just so happens that this graph, M double prime is F prime. Where are the F primes, slopes on this graph? Negative. 0 to 3. And that's it. Don, does that make sense? Be honest. Good? Wendy. M is concave down on 0 to 3 because M double prime of x, which equals F prime of x, is negative on that interval. Don't say decreasing. Negative on that interval. Please keep those words straight. Okay? All right. I'm not going to have time to do this one, but what are you going to have to do for this one? Break up the graph. How many different zeros did sine have between 0 and pi over 3? Well, sine of 0 is 0. Then pi. Is that it? Yeah. So you're just going to have two portions here. Find both areas. One of them is going to be negative. Make it positive. Add them together. So what would I want to see on the quiz tomorrow? Integral from 0 to, where is it? Where's its first 0? Good. Pi. Sine of x dx. And then the integral from pi to 3 pi over 2. Sine of x dx. Won't have a calculator. So you'll have to like either anticipate. I'd prefer you don't try to anticipate. I would do the math. Find out which one's negative. Make it positive and add the areas together once they're both made positive. Make sense? Total area. Are you good on that? Okay. Practice it. Check it. Be confident with it. All right. While you guys are taking your laptops out, do not start the quiz. Actually, I don't think you can. I made a password this time. I'm getting fancy, friends. Okay. By the end of the year, you're gonna be like, he's a technology wizard. While you're taking your laptops out, I will tell you about the groups for tomorrow. Group 1, we got Logan, Tessa, and Hayden. Group 2, we have Casey. Try to keep your reactions to a minimum. It might be less offensive to others. All right, Group 2, we have Casey, Cole, and Avery. Group 3, we have, I'm sorry, with a C. Cole with a C. Soft Cole. Not soft Cole, like soft. Like, K is just hard. It's like harsher Cole.
K is harsh.
Cool.
K is a harsher letter.
Group 3, we got Gavin, Robert, and Adam. Group 4, we have Wendy, Harsh Cole, and Tyler. Group 5, we have Mason, Dom, and Lizzie. Group 6, we have Madison, Kylie, and Lane. And Group 7, the Quad. We have Jaden, Tony, Jackson, and Luke.
Oh, wow.
For real.
If they want to break up into two separate groups of two, that's fine.
Yeah, Jackson and Christian.
Dang.
All right.
That should be fun.
All right, we're going to start this all at the same time. We're going to make this a little interesting. Are you ready? This could be a reality show. I'm going to record tomorrow's. Huh?
This is going so bad. Hey, don't bully me. I get back to you.
Madison.